Welcome guys. Today we're going to be talking about the fundamental counting theorem and factorials, so let's just dive right into it. First, the fundamental counting theorem. I have the definition listed right here. It's basically a way of figuring out the number of outcomes in a probability problem. And so we do have a little bit of a formula here we can use to figure this out. And basically when you have different events, you're going to multiply those events together to get a total number of outcomes. And the formula would be if you have event A and another event B, then all the different outcomes for these events would be A times B. So here's an example of what the fundamental counting theorem is. Let's say we have a fast food restaurant, and for $5, you have to choose a drink, a sandwich, a side item, and dessert. So $5, you get all of that, which is awesome. That's an awesome meal. So for your choices for sandwich, you can choose grilled chicken, a beef patty, veggie burger, or a fish fillet. For your side, you can choose regular fries, cheese fries, or potato wedges. For dessert, you have chocolate chip cookie or an apple pie. And as a drink, you can choose Fanta, Dr. Pepper, Coke, Diet Coke, or Sprite. So what we want to know using the fundamental counting theorem is how many different combinations of these meals are possible. So how many different types of meals can I get out of this? Say I want to come every single day and get a different type of meal with at least something different every time. How many times would I have to come back to get that? So let's look at it this way. There's 4 stages when choosing your combination of your meal. So first stage, you got to tell me what kind of sandwich you want. Grilled chicken, beef patty sandwich, veggie burger, or fish fillet. Then stage 2 is choosing your side, and then stage 3 is choosing your dessert, and stage 4 is choosing a drink. So there's 4 different types of sandwiches. There's 3 different types of sides to choose from, 2 desserts to choose from, and 5 different types of drinks. So, as I explained before in this formula right here, we have events A, B, and we'll call the other 2 events where the dessert and drink A, B, C, and D. We have to multiply all 4 stages, all 4 events, to get our possible outcomes, all the meal combinations we can come up with. So we have 4 types of sandwiches. So we have 4 as event A times event B, 3 different types of sides, event C, which is 2 different types of desserts, and then 5 different types of drinks for D. So 4 times 3 times 2 times 5. That's going to give us 120 different meal combos, meaning if I really did want something different every single day, I would have to go 120 days to get a different meal every single time, something different in my meal every time. So that's how many meal combos we can do at this fast food restaurant. So now let's jump into factorials. This is pretty simple. Basically, they're products indicated by an exclamation mark. So if you ever see like this one with the exclamation mark, that is a factorial. So for instance, 4 factorial is 1 times 2 times 3 times 4. So anytime you see a factorial sign, the exclamation point sign next to a number, you're basically multiplying from that number, number 4, let's say, down to 1. So 4 times 3 times 2 times 1. So it's the product of all whole numbers from 1 to n being the number you decide to choose, where we said right now earlier 4 was going to be our n. So let's look at these examples right here. We have 1 factorial. Well, we're making n equal to 1, but we said that the product of all whole numbers from 1 to n. So if n's already 1, then we're just done. 1 factorial equals 1. Let's look at 2. So we're making n equal 2. Sorry about that, guys. So we're making n equal 2. So what you have to do is from 1 to 2, 1 to n. So 2 times 1. We have 2 factorial equal 2. When we look at 3, it's the same thing. We go from our n is 3, so from 1 to 3, 3 times 2 times 1, that equals 6. And so on and so forth. You'll keep doing that. So our next example, what do you do when you get a factorial where you have to divide? So right here we can see we have 6 factorial divided by 4 factorial. So again, we use what we just learned. We made n equals 6 on the top, so we have to do from 1 to 6 on the top. So 1 times 2 times 3 times 4 times 5 times 6. And we do the same for the 4. n equals 4 on the bottom, so we do 1 through 4. Now, when we look at division, we can use our handy tools we've learned in the past of eliminating like terms. So instead of figuring out what 1 times 2 times 3 times 4 times 5 times 6 equals, and then doing the same for the bottom and doing all that work, we can just cancel out like terms, as you can see right here. So we can cancel the 1s, the 2s, the 3s, and the 4s. What are we left with? Just 5 times 6. 5 times 6 is 30. So anytime, guys, you see any kind of division with factorials, try to find like terms. Write it out and eliminate what's the same so that we can make this problem a little bit easier in the future. And one last little tip, I'll go over it more in class, but anytime you see a 0 factorial, that is defined to be equal to 1. It does not equal 0. Do never ever put 0 factorial equals 0. Memorize that 0 factorial equals 1, and then we'll go over more in class why it is equal to 1. All right, guys, thank you for participating and listening to this. I'll see you in class.